Next one, now we'll go directly to our next lesson. You should introduce it first by our objectives. So the first one, our lesson, it is making magnet, how we can make a magnet. Discuss difference between temporary and permanent magnet. Demonstrate the methods and making temporary and permanent magnet. Use a simple electric circuit to make electromagnet and so forth. Next, how we can make a magnet. Actually, we can make it magnet even in your home. Are you with me? Yes, we can make a magnet. Look how we can make a magnet. Follow me step by step, my students. Okay? Yes, first one. We can make a magnet actually by different components. You should have first piece of magnet material and electric current, so it will magnetize by induction, as you're going to see from the previous lesson. So the magnetic field, you can be permanent. You know what I mean permanent? That means it will take a long period of time. It will work long period of time, and sometimes it is temporary. Temporary, that means it will work, for example, today and tomorrow it will not work. So it's called what? Temporary. So it's called temporary, and also it's called also permanent. Permanent, that means it will so strong magnet, but temporary is not so strong. It will work today maybe, and tomorrow it will not work. Look how we can make a magnet. So actually from electricity we can make a magnet. You know that? Yes, from electricity we can make a magnet. How that? Look, the magnet actually, the plus electricity plus a magnet, we can make what? An electromagnet. How this one will form? How you can be? Look, we can take a battery. Yes, we can make a battery here with a wire, two kinds of wire, and we can take a metal. So the wire should be placed in this metal. Yes, in this metal, one here and one other side. So this metal, it will be like what? Like a magnet. So we can make a magnet from electricity. Look for here for the paper clips here. The paper clips are attracted by the metal. Are attracted by what? By the metal. For example, we can use this one. Use it for this one for the crane. You know the crane? The crane, that one is like a machine that transport things from one place to another. That use what? An electromagnet. Why is it called electromagnet? So that's mean forming magnet from electricity. You know that the battery is a source of what? Of electricity. Thank you. So look for the crane here. The crane here, we are using what? We are using electricity. Electricity, it will pass by wires, and we have here a metal. And look for the big metal, large metal here. All those are the irons, the different kinds of wire. It will what? It will attract to the metal. So this one is called what? Crane, that use an electromagnet. It's very powerful electromagnet. Let's go now to the next lesson. It is lesson 21, the Earth magnetism. So, Earth magnetism. Inside the Earth there are a magnet, mister? Yes, sure. Yes, in our Earth there are a magnet. The magnet inside our Earth, it is very, very, very strong. Yes, it's very strong inside the Earth. The majority of people, they said, or the majority of scientists, they said that we have a magnetic field in our Earth. So this is our globe, and look, as he said from the beginning, the magnetic line or the magnetic force will pass from the north to the south. Excellent. So this one is called what? Geographic South Pole. But this one is called what? The geographic North Pole. Our Earth is like what? It's like a magnet. Caused by what? Okay, this is the question. Caused by what? The magnetic field inside our Earth, inside our planet. Yes, perfect, excellent. Caused by what? By the inner core. Caused by the inner core inside our planet. So, this is the magnetic field inside our Earth that we can use also another kind of tools used by the sailors when you're going to transport it from one place to another by using ships, by using boat. Inside the sea, we cannot identify the direction. So we'll use what? We'll use a compass needle, as we seeing here from this picture, is called what? The compass needle. So the compass needle use what? Use a magnet that identify the north. When identify the north inside the sea, we can understand our direction. So this one is called what? The Earth magnetic pole. The Earth magnetic pole, we have the North Pole and we have the South Pole. Next one now. Take a look for this short video that you can understand better. Okay? Okay, we're going to take a look for this video first.
How do you like my new look? Today we'll learn about magnets and magnetism. Hey buddy, don't worry. Let me help you.
Look.
Surprised? It's not a magical instrument. It's a magnet. A magnet is a rock or a piece of metal that can pull certain kinds of metal towards itself. The force of magnets is called magnetism. There are three main types of magnets. Temporary magnets. In this type, when the magnetic field is removed, the object gradually loses its magnetism. Permanent magnets. Once they're magnetized, these objects do not easily lose their magnetism. Electromagnets. These are used when a very, very strong magnet is necessary. An example is thermal radiation. Magnetism works over a distance.
As he said,
this means that
so the magnet can be three types of magnet, he said. So the first one, it is temporary magnet. The second one, it is permanent magnet, temporary magnet. The third one, it is electromagnet. And then now, we will continue our lesson. So our lesson now, it is about what? About the Earth magnetic pole. We can continue this video, my best student. We can continue the video until the end, that you can understand better and you can identify many things. Okay? It might do the movement of large amount of molten iron inside the Earth. So the Earth magnetic pole is caused by what? Is caused by the iron. There are a molten iron. You know what's mean molten iron? It's iron, but it is melting, caused by the heat and pressure. Inside what? Inside the Earth core. Inside the central Earth core of our globe. The compass can be used to detect the Earth magnetic field also. The compass needle, as we said, this one that we can use it by the sailors. Okay. Next one. So this one is a needle compass. So we can use it to detect what? To detect the Earth magnetic field. Perfect. Thank you so much. So, and then now we'll go directly to speak about the compass. The compass have a magnetic needle. This magnetic needle, as you're going to see here. So this one is a magnetic needle. The magnetic needle, I'm going to see it. It is balanced by what? By pivot in the middle, in the center. By the pivot, it will work. It will work when you change our direction. It will work. It will move. This, it is the needle. The Earth magnetic field is weak. When it is weak, so the compass needle has to be very light and sensitive. So that's why the Earth magnetic field is weak. It's not very strong. So if it is very strong, so the car, it will not move clearly, and we cannot move from one place to another. So can you tell me why? Because the car actually it is formed by iron. So that's why the magnetic field is very weak. So that's why we need to use a needle very light and sensitive. The stronger magnetic field nearby, the compass will point in one direction. So this one is a needle compass or compass needle. If you need a use compass, make sure no magnet near of this compass. No magnet near of this compass. We don't need to use a magnet near of this compass. When you're going to use a magnet, another magnet with a compass, so the indication, the compass, it will what makes our direction wrong direction. So that's why the majority of sailors that use and navigate at the sea or ocean by using this needle compass. Thank you so much for your attention, my best student, and see you next lesson. Thank you.